Well, welcome everybody. Our speaker today is Paul Beckwith, well-known climate system scientist, physicist, engineer, educator. He'll address how weather wilding, weirding, whiplash is, I like that one, is wreaking havoc, imperiling our ability to grow food, among other problems. His presentation will be followed by a conversation, questions, observations, not just from the participants, but I expect that there'll be responses from Paul as well. So Paul, if you will.
Yes, hello everybody. And as you're probably aware of, KCOR, or the Club of Rome, has been in the news since some of the original work done in the 70s, 72, I guess, the limits to growth and the idea that, human civilization was on a path to perhaps collapse, that's apparently happening right on schedule, according to some of the recent news reports. So, what are some of the reasons for this? There's a myriad of reasons, but I'm going to talk obviously to climate change. Now, I'm trying to get you to think on a sort of system level. So we're not just talking about the atmosphere, but we're talking about all of the systems of the Earth and how they're part of the climate system, really, and how they're changing. And humans are basically linear thinkers. We expect things to change incrementally over time. But the natural world is often not like that. There's very strong, what we call scientifically, nonlinearities in the system. And this is where you get the forcing, the thing that is causing the actual change is can still be relatively small, but there's points when the system can abruptly change from one state to another. And the concepts of passing a threshold and tipping points come into play. Just think of being in a canoe and you're tipping it from side to side and it's stable if you stay within limits. But if you pass a certain limit, a certain angle of tipping, then you go into the water and you're in a new state. Any phase transition, like liquid to solid, as you lower temperature below the freezing point of water, for example, as long as you're slightly above that freezing point, you've got a liquid state. But you hit that, and you could be, a millionth of a degree, above and still be in the liquid state. And as soon as you reach that temperature, that threshold, where you get a transition from a liquid to a solid, obviously you get a massive change of state, or an abrupt change, if you like. So, by the word abrupt, I'm using to mean some change that occurs much beyond what is driving the change, the forcing. For example, and there's different stable states that we can be in. And the best example of a stable state versus an unstable state is you've got a ball rolling in a hill. And if you're in the valley of the hill and you push the ball to the left or to the right, it will return to its original resting point. So that's kind of a stable system. Whereas if the ball is on top of a hill and you give it a slight push off the peak of that hill, then it will rapidly roll down the hill, accelerating, getting further and further from the original state. So that's clearly a highly unstable state. Now, most of the Earth processes, unfortunately, are like the hill. They're not like the valley. So let's get to the sort of the climate, what you really need to think of the system. So think of, the sun is heating up the Earth, but it's heating up different parts of the Earth, different amounts. Okay, obviously the equator, gets more sunlight and the sun is more directly overhead, so it gets a lot more heating and it's warm. And the poles are heated the sun's at an angle with respect to the poles. So the light is traveling a much longer path length. There's much less light intensity because, you know, think of taking a flashlight and shining it on a wall, you get the nice circular spot. And now stand along the wall and shine it at a glancing angle on the wall, and the beam is spread out into a large ellipse. So the area that the light is falling on is much larger. So the energy intensity, the energy per unit area is much smaller. So this is the case with the poles. The poles are getting a lot less energy, so they're cool. So the heat tries to go from hot areas to cold areas. So it tries to move from the pole to from the equator to the pole. And it does this in both the atmosphere and the oceans, the movement of fluids, the movement of air in the atmosphere, the movement of water in the oceans. About 2/3 of the heat is carried from the equator to the poles, whether it be the North Pole or South Pole, via the atmosphere. And that movement of air creates the jet stream type behavior. In the oceans, it's the currents, like think of the Gulf of Mexico moving north off the east coast of North America, and then crossing over the ocean towards Europe. Okay, that's the surface moving component of the ocean circulation system. Now, what's happening is that the heat distribution, the heating of the Earth is completely non-uniform. Okay, clearly, as you move further from the equator, we're getting more and more heating. And there's other factors in play. For example, you know, if you're in a continental climate, if there's no water bodies near you and you're in the middle of a continent, then the heating can be much greater in those regions than it is obviously over the ocean, which is a big thermal sink for heat. So the air currents, the air taking that 2/3 of the heat from the equator to the pole, the amount of flow depends on the temperature difference between the Arctic, in the case of the Northern Hemisphere, and the equator. Now, the Arctic has been warming at much, much faster rates than the equator. Also, the Antarctica is warming much faster than the equator. And the reason being in the Arctic is that the Arctic is becoming a much darker place. Physically, the surface is becoming much darker. It's becoming much more like an asphalt driveway than a snow-covered field, for example. So the main reason for the Arctic becoming a darker place is that we're losing the Arctic sea ice. The area or extent and also the thickness of the Arctic sea ice is declining at ever faster rates. So there's much more of the Arctic Ocean is exposed to the atmosphere. There's much less sea ice there. As long as there's sea ice there, then the temperature just above the ice is just slightly above zero. The sea ice acts as a refrigerator mechanism to keep the Arctic cold, as well as the glaciers that are on Greenland. And they also keep the Arctic a very light, white place, you know, very highly reflective surfaces. In fact, NASA satellite instrumentation called CERES, C-E-R-E-S, you can Google any of these things if you want to check. Anyway, this sensor, about 20, 30 years ago, told us that the average reflectivity of the whole Arctic region was about 52%. So 52% of the incoming light was reflected out. And now it's more like 48%. Okay, so the Arctic is darker because there's a lot less sea ice and there's a lot less, even the glaciers on Greenland are darker because the snow regime is changing. And as we get more and more melt of the ice on Greenland, all of the impurities in the ice are exposed, making the surface of of Greenland darker. And also we're getting types of bacteria and things, growing, algae within the ice that are also making it darker. So the Arctic is actually warming. For years and years, the media would say the Arctic's warming at twice the rate. Okay, and this has always been incorrect. It depends on what latitude you're at, but the number is, if you just look at the raw numbers, the Arctic is warming at about 3, 4, 5 times faster than the rest of the planet. The farther you go up north, closer to the North Pole, the quicker, the larger the rate of warming of the Arctic relative to the rest of the planet. So what this means is that the Arctic temperatures are getting much, much higher relative to the equator temperatures, which are going up, but not as quickly, nowhere near as quickly. And this is important because that temperature difference determines is the reason why we have a jet stream. So a jet stream is high altitude stream, very fast moving air. I'm sure you're familiar with the jet stream from, for example, the Globe and Mail weather report showing where the jet stream is, and it shows. So basically, the jet streams are very important for weather patterns and weather systems because they guide storms, they guide circulation. The reason why the winds in Ottawa are mostly from the west to the east is because of the global circulation pattern, which is related to which the jet stream is related to. And it has to do with the way the Earth is rotating and the way the winds deviate. Any moving object in the northern hemisphere gets deflected to the right because of the so-called Coriolis effect. And we didn't know much about that before World War I, but when the big battleships were firing their shells at other ships, they kept missing to the right. And eventually it was figured out that yes, it's because of the Coriolis force, so they had to aim to the left of the ship that they wanted the target to have the shell actually curve to the right and hit the ship. But we really didn't think about it too much before, but it's fundamental to the weather patterns that we're seeing. So the jet streams move from west to east and they circumvent the planet at high altitudes, and they guide weather patterns, and they act as a wall between colder, drier air from further south, or colder, drier air from the pole. They separate that from warmer, humid air from lower latitudes. Okay, now the jet streams are slowing down and becoming wavier and becoming stuck in place. And when I say wavier, I mean in the north-south direction. And they're doing this because the Arctic is undergoing much faster warming than the rest of the planet. And because they're moving slower, what it means, well, first of all, under these waves of the jet stream, you might have about 6 or 7 waves traversing the circumference of the Earth at high latitudes for the jet stream. And when the waves form a crest, it can go very, very far north, and in fact, even go up to the North Pole. And the trough of the wave can extend very, very far south and even reach the equator, and actually even connect with jet streams in the southern hemisphere and cross the equator. The important thing to know is that under the ridges, you have things like the heat dome, which we've been experiencing in lots of, mostly the western parts of North America. And in the troughs of these jet streams, you get weather patterns. You get lots of unsettled weather, lots of storms, lots of rain. And what we're seeing now, over the last number of years, we've had more and more extreme weather events around the planet because the jet streams have become wavier and wavier. So, even a good example of a really striking event was in 2010. The trough of the jet stream covered most of Pakistan, and the ridge of the jet stream, that same jet stream, covered over Moscow and lots of Russia. So in the trough where Pakistan was, it rained just about every day, and it was persistent. This pattern held fast in place for many, many weeks, from July to through late June, part of July. So in Pakistan, it rained almost every day in the trough, very unsettled weather, and 3/4 of the country experienced severe flooding. In the crest of the jet stream over Russia, it was extremely warm heat waves. Russia lost about 40% of their grain crop, and they weren't able to export grain that year. There were grain shortages, and we had the Arab Spring being triggered at that same period of time. More recently, what's been happening, say, in the last few months, is that we've had this tremendous ridge of the jet stream over Western North America. And we've had the heat dome, so-called heat dome, and heat waves, and drying, and failure of crops, and drying out of forests and things. Even some storms where lightning was produced, but no rain, and triggering all of these wildfires. And with the ground so parched, and having had a fairly decent rainfall leading up to this heat dome and heat wave, there was lots of vegetation on the ground, which then dried out and became fuel, if you like, rocket fuel for these wildfires. So that's the crest of the wave of the jet stream. Well, guess where the trough has been from that exact same wave that circumvents the Earth? The trough has been over Europe. In fact, the jet stream split. So part of it was going north of Europe, part of it was going south, but so it created this, what's called a cutoff low. It's not just, which is, similar to just what's happening in the trough of the jet stream. And we had torrential rains in Europe. We had tremendous amounts of rainfall. And of course, that rain, in rugged, hilly part terrain in Europe, that water had nowhere to go but into the small river and creek basins, which normally had decent flow rates, and suddenly, they're inundated with water, and that water just tore through many small towns along the route, and completely, you've seen the pictures of the cars floating and houses being swept away. Okay, so these, because of the waviness and slowing down of the jet streams, we're experiencing huge numbers of extreme weather events. Okay, the frequency of these extremes has gone up. No longer can we talk about a 1 in 100 or 1 in 1,000 year event, because it's liable to happen one year and happen in a few years. The severity of these extreme weather events has also increased, whether it be the severity of a drought from a heat wave, or the severity of the rainfall. So in China, just recently, one region of China, which was in a strong trough of the jet stream, and you can see what the jet streams are doing, by the way. Just Google Earth Null School. One word for a null school, N-U-L-L school. Just Google Earth Null School. Open the application on your computer or smartphone. Click on Earth in the bottom left corner. If you want to see the jet streams, make sure just select that you're looking at the winds, and you're looking at the winds at a pressure level of 250 millibar, which is roughly the altitude or the pressure at where the jet streams are. And you can see the jet streams circumventing the Earth sort of real time. Then go back to the, focus on Germany, for example. Look at the, find the date when the rain started in Germany and how long it lasted, and just check those dates out on this application, and you can see the shape of the jet streams over those regions, the troughs. You can look at the precipitation or the water vapor in the atmosphere or any other parameter, just play around with that application. And you can see exactly what it looked like to cause that extreme weather event. Also, the extreme weather events are occurring in regions where, well, I said the frequency they're happening more often, higher frequency. They're more severe, they're more intense, okay? They're also of longer duration, because think of a huge storm complex moving across the surface of the Earth. And with the slower jet streams, it's not moving as quickly across the Earth. So it's staying in one spot for longer, and we're getting torrential rain events. Whereas it's not reaching areas it used to reach before, so we're getting drought events there. So the other thing is it's happening, so duration is longer of the extreme events. You know, the droughts and heat waves are lasting longer. The torrential rains and leading to flooding are also lasting longer, dropping more water. And so the duration is increased, but also these extreme weather events are happening in regions where they did not happen before. For example, you know, some of the hurricanes that we're getting, instead of just being confined to the Caribbean, you know, hitting the US South, some of them are actually curving around and being hurricane strength in, you know, the British Isles, Ireland, for example. Other hurricanes have actually hit Brazil. So these events are happening in regions where they never happened before. For example, you know, the Atacama Desert, one of the driest places on the planet, they're lucky to get a few millimeters of rain or a few centimeters in a decade. Suddenly they're inundated with 20 or 30 centimeters of snow, okay, in one particular event. Okay, so these sort of things are, you know, these extreme weather events, I actually coined a number of different names for them. And, you know, copying people, when people copy what I've done, of course, I just take it as the sincerest form of flattery. But, you know, I started thinking of ways I could describe what's going on with the extreme weather events, I don't know, 5 to 10 years ago almost. And you know, I came up with weather weirding, weather wilding, and weather whiplashing. You know, the idea of weather whiplashing is, you know, we've experienced it in Ottawa, for example. You know, in 2017, the Ottawa Valley watershed was inundated with, had a heavy snowpack and had rain events, rain on snow events and rapid melting. And we got flooding of the Ottawa River through Ottawa. Gatineau, you know, severely hit. The very next year was very, very low level of water. And then in 2019, but we did have the tornadoes that year to make up for the flooding, right? And then in 2019, of course, we had the, you know, a flood that even exceeded the 2017 flood. You know, the Mississippi River has done a lot of this. It's a good example of weather whiplashing. You know, one year there's record flooding in the watershed and the water collects in the river. So there's record levels of flow in the Mississippi River, and it impacts detrimentally the shipping that goes on there, the shipping of grains, the shipping of steel. You know, it's sort of a hub of economic transport in the US, the Mississippi River, and that was severely curtailed during that flood year. Then the very next year, after that flood year, they had record low rainfall, record low levels of the Mississippi. In fact, the Mississippi River was so low in places that ships could not traverse those places. So the US Army Corps of Engineers had to end up dynamiting rocks off the bottom to clear passages for the ships to cross. Then the third year, after that, you had record flooding again, only this flooding, it far exceeded the flooding, the previous record from just two years prior. Okay, and then they had to do a lot of triage because the flooding was so bad, it was threatening to cause tremendous damage in some of the major cities along the Mississippi. So because those places have more political clout than some of the rural areas, they actually convinced the Army Corps of Engineers to open some sluiceways and dams and flood out farmers in some rural areas to protect the city. So this was a form of triage that they did. So we're getting more and more of these extreme weather events. So where does it go from here with the extreme weather events? Well, obviously, as you would imagine, that as the Arctic continues to lose the sea ice, and I didn't mention the snow cover, because the snow cover on the land in the Arctic has also been declining. In fact, it's been declining more quickly in the spring than the loss of the sea ice. In terms of the area that used to be covered in white snow, and now in the case of the snow cover, it's the darker land underneath that's exposed. That particular area is actually on par with the area of ocean being exposed from loss of sea ice. So the snow cover and the spring effect is having just as large an effect on the darkening of the Arctic as the loss of sea ice is. But where are we heading with this? Well, obviously, we're heading to a time very soon, could be within a few years, when there's no Arctic sea ice left at the end of the melt season in September. Okay, so say this happened, say this happens, call it year zero. And I came up with a phrase for this, a couple things with the Arctic. I came up with the expression on a CTV interview when I was doing some volunteer work for the Sierra Club. CTV came in, and I was talking about the Arctic melt and how it related to the rest of the planet. And I said, what happens in the Arctic doesn't stay in the Arctic. It's not like Las Vegas. Okay, so this is the quote that I didn't think of it before the interview. It was just while I was being interviewed. And I'm sure you've heard that term. Many people have said it, even John Kerry and politicians, scientists. I mean, it's a good term. I should have trademarked it, but it doesn't matter. Same with the terms weather weirding, wilding, whiplashing, all these things. A paper just came out a month ago on weather whiplashing events, and it's looking at the different modes of the atmosphere and how you have a large scale change from one mode to another mode, and you could get a huge swing in temperatures, and that's very detrimental to infrastructure. It's very detrimental to the biosphere, etc. But they categorized it scientifically and did an analysis of how many events are occurring, and they found that yes, the more the Arctic is warming, the more weather whiplashing events there are. Okay, so anyway, where is the Arctic going? I coined the phrase blue ocean event many years ago. I said, okay, when we lose all Arctic sea ice, I'll call it a blue ocean event. There's no ice on the ocean anymore. It's just a blue ocean. Okay, so let's say, I fully expect that this situation will come about in the Arctic it's a probability thing. There's a lot of variability with weather in the Arctic. Some years are colder than others. It depends on which way the winds are going. It depends on other factors. But one year, very soon, we'll lose the last of the Arctic sea ice come the end of the melt season, which is mid-September of some year. Say 3 years from now, next year, this year, 5 years, who knows exactly when, but it's going to happen very soon. And I mentioned to you that the ice acts as a refrigerator in the Arctic. So when there's it wouldn't stay permanently lost, of course. The ice would disappear for a week or 2 weeks or the month of September. And we'd have a completely open Arctic Ocean, which has tremendous ramifications on the planet, as you might imagine, and on the jet streams and on the extreme weather events that we experience around the planet. So that would be the first year. And then, of course, when the ice regrows back in the fall and in the winter, we're seeing the ice is not growing as well in the winter. Winters are much warmer, so the ice thickness is getting thinner and thinner and thinner. And probably within about 2 years after the first blue ocean event, we'd have a completely open Arctic Ocean for maybe August, September, and October, for 3 months. And then within another 2 or 3 years, tack on another month, we'd have no sea ice for July, August, September, October, November. And then within probably a decade of that first event, no Arctic sea ice year-round in the Arctic. Will have flipped into a completely different state on our planet. And it's going to, the biggest ramification that I can see on our planet, apart from the great increase in extreme weather events and torrential rain events and droughts and floods, etc., because they're going to be controlled less by the jet stream patterns and more by local patterns, like the land-sea contrast, for example, topography, mountain chains, etc. Things are going to, different patterns will be set up and established, but there's no new normal. Okay, this is when you're going through an abrupt, rapid change, there's no new normal. You have different ongoing extreme weather events occurring. So we're basically gonna have a real problem to produce enough food to feed the global population. So we're gonna have global food shortages. We're going to have simultaneous crop failures. We're going to have problems in distribution of food, and I don't see how we're gonna avoid global famine. Okay, and I'm talking near term. I'm talking in the next decade. Okay, and relating this to what's going on in the Arctic. Okay, now we can talk about some more of the specific things. Like, it's not just the atmospheric patterns. So I'm talking about, go back to the big picture. Okay, the equator is warmer, the poles are colder, heat moves from the equator to the poles. It does it in the atmosphere and oceans, 2/3 in the atmosphere, 1/3 in the oceans. The changes in the oceans, we also have extreme ocean events, but we don't really talk about them as much. We don't recognize them as much. We're landlubbers, right? But the oceans are vital to the climate system and the patterns of weather that we see, et cetera, et cetera. So we're seeing ocean marine heat waves, if you like, already. So we've had marine heat waves off the west coast of North America that killed vast amounts of marine creatures. Even the heat wave, the heat dome, which covered Western North America, there were some tides, high tides, when we had the timing coincidentally with the heat wave, with the hottest part of the day, and that shallow water on the coast heated up enough in a few hours that there were massive kills of shellfish and marine creatures on the coastlines, of salmon in the rivers and things like that. So we're really, our biosphere is suffering tremendously. We're getting mass die-offs of animals at certain times. In fact, I'm working, somebody who's following me on Facebook has been keeping, and Twitter has been sort of documenting the news that they see, and just getting a spreadsheet of all of the incidents over the last number of years of massive kills, whether it be birds dropping out of the sky, or massive fish kills in rivers, or whatever it is. Okay, they're documenting this, and you can find somewhere around the world every day, you can find mass kills of some sort, some species or other, from these extreme weather events. And I mean, we've lost stability in the climate system. We've lost stability in the weather system. And of course, you know, we're seeing it mostly, you know, in our infrastructure, right? We're getting, you know, in the Arctic, for example, the permafrost is thawing and its ability to support structures is compromised. So we're getting trees leaning on their sides. We're getting lots of coastal regions of the Arctic that are getting severe erosion from not only from the thawing of the permafrost that's underlying the surface of the ground, but also, you know, with less and less Arctic sea ice in the ocean, the wind is able to blow over the water, and you know, the size of the waves depends on the wind velocity. It depends on the fetch, which is the distance it blows over the open water. And it depends on the duration that the wind is blowing over that open water. And if all those things are longer, then you get bigger and bigger waves, you know, and add the waves from storms and so on, storm surge. And you get tremendous amounts of coastal erosion happening also in the Arctic region. So you know, we've changed the chemistry of the atmosphere. We've changed the chemistry of the oceans, and we're seeing the consequences of this now. So, you know, we're continuing to set record levels of greenhouse gases in the atmosphere. You know, CO2 is the one we talk about most, but nitrous oxide is also rapidly rising, as is methane. And unfortunately, these things didn't stop rising during the 2 years of reduced industrial activity due to the worldwide pandemic. Okay, so the problem is that a lot of the Earth processes that capture carbon naturally, the so-called carbon sinks, are reducing in strength. For example, the Amazon rainforest used to be a tremendous sink for carbon, and because of the burning and the loss of the Amazon rainforest and the high temperatures, that's no longer the case. It's actually turned into a source of carbon. The oceans absorb vast amounts of gas, of CO2 and oxygen, of course. Oxygen is vital for the marine life, but the CO2 in the oceans is making the oceans more acidic. So the acidity of the open ocean used to be about 8.1 on the pH scale, and that's decreased to about 8.1, 8.2 actually, and that's decreased to about 8.05, which doesn't sound that much, but it represents an increase of acidity in the ocean by about 30%, because the pH scale is logarithmic. So the increased acidity of the ocean makes it problematic for creatures that rely on aragonite or calcite, which is basically different forms of calcium carbonate. They make their shells, their exoskeletons of some of these tiny plankton, for example. And when the ocean's too acidic, the calcium carbonate just dissolves, and you have a huge impact on the species. So this is a huge problem. The ocean, because the ocean's a lot warmer, warm water floats on top of cold water because it's lighter. So with a much warmer ocean, we're getting more stratification of the ocean, more layering of the ocean with the hot water on top, colder water below. So there's less mixing going on. And as a result, there's less oxygen going down, and there's less CO2 going down from the surface to deeper depths. It's important that the CO2 go down because the ocean is a sink of carbon, but the oxygen needs to go down to allow marine creatures with gills to extract that oxygen from the water And if there's less oxygen going down, then you get these oxygen dead zones, which are mostly a problem in shallower regions. For example, at the mouth of the Mississippi, where you have a lot of fertilizers in the water because they've been used on the fields and crops upstream, you know, in the plains of the Mississippi, the floodplains, and then getting into the river, and then that water heavily laden with phosphates and fertilizers goes into the Gulf, causes phytoplankton blooms to occur, and then there's so much plant there that it can't be sustained, and it dies or it's eaten, and if it dies, it sinks to the bottom. If it's eaten, then it's pooed out and it's excreted out and goes to the bottom, and then it uses up all the oxygen and creates these anoxic zones, which are, and we're getting more of these around the planet too. Also, there's less phytoplankton. We think there's quite a lot less phytoplankton than there used to be. And of course, phytoplankton is vital for producing oxygen that goes into the atmosphere that we breathe, along with any other plants. The boreal forests, you know, think of all of the carbon offsets, okay? So if you go and fly and then you get some trees planted somewhere by, you know, these carbon offsets, well, unfortunately, a number of these wildfires that have been going on have been actually cutting through and destroying, you know, any regions that had trees planted for carbon offsets. You know, the idea of using the idea that trees, the climate models assume that these trees are going to be around for a long time. We're seeing, you know, we're experiencing the fallacy of that argument. You know, those trees that you're breathing in that have metamorphized into particulate matter that is crossing across North America, that you're breathing in, that is blocking the sun, and you know, that we're experiencing is really affecting you know, people's way of life, what they're doing, where they're going. It hasn't had a huge, it's affecting lumber supplies as well. But you know, the reason lumber price, you know, if you built a deck, you know, if you built a deck this early spring, you would have paid 4 times more than you would have paid a year or so ago. I mean, the prices of lumber has dropped 70%, but this is mostly, you know, a supply issue, you know, everybody having time on their hands, wanting to do it yourself projects and so on. So the prices plummeted, but, you know, the wildfire, you know, think of a large hurricane, you know, devastating a town in the US, and think of the demand for lumber and all of the other all the trades to rebuild, you know, all that devastation. I mean, what you can see what's happening. It doesn't require being a rocket scientist to say, okay, you know, as more and more of these extreme weather events take out cities, destroy infrastructure, you know, now there's no question about what we do. The politicians step up and say, we're just going to rebuild everything. We'll just rebuild everything in the same place. I mean, you know, is this, eventually there won't be money to do this, right? People won't be able to insure their houses because insurance rates will just be too high. Insurance companies.
5-minute warning.
Oh, already? Okay. Okay, sounds good. Thought I had another few hours. Okay, so basically we're you know, and it's funny because if you know me and you know my work, you know, I've been talking about this sort of thing for probably close to a decade. You'll know that people considered what I was saying as alarmist and, you know, ridiculous. I'm going off on my, you know, my rants or whatever. Now, finally, you know, now, and I said, well, I don't care, you know, think of what I'm saying as being absurd. You know, you might change your tune in a few years. And mainstream scientists are extremely concerned, all of them, or if they follow what's going on now. You know, Canada, Lytton, BC, reaching 49.6 degrees. setting temperature records Monday, Tuesday, Wednesday, reaching 49.6, and then going up in smoke on the Thursday in about 15, 20 minutes from the smoke was sighted. And then 15 minutes later, everybody was fleeing for their lives from their houses. This isn't new. This happened in Paradise in California just in 2018. The amount of forests that Canada has, right? Just stretch your imagination when, the fires now aren't being controlled. What's going to happen in a few years when we have more and more, heat waves and drought and so on? The Intergovernmental Panel on Climate Change report comes out about every 7 years. Working Group 1 is the science basis. People are going through it. Scientists are going through it line by line to see what they can keep in and what they can't. There's been some leaked drafts, but the report is due on August 9th. Okay, and that's going to be an eye opener to a lot of people. If it's a completely truthful, honest report, not holding back, then it's going to actually illustrate how dire the science is. I've said what we need to do. I mean, the whole root of the problem, the biggest thing we can do is our government still subsidize fossil fuels to the tune of about $3.9 trillion in the last few years. $3.9 trillion. Okay, we have to slash fossil fuel usage. We have to deploy carbon dioxide removal techniques, and we have to deploy solar radiation management techniques to buy us time to do the first two things. Otherwise, and maybe we can stave off a global famine. Maybe we can stave off, some of these other things that are coming in the pipes as our weather patterns continue to completely shift and change under this abrupt climate change regime. And I call it mayhem. I can't describe it any other way. I was on a CTV interview just last week, and it's posted online, the interview. And, I was talking about the wildfires and the air pollution, the particulate matter, and, why Ottawa was seeing a lot of air pollution and so on, and, the health effects. I mean, 8.7 billion people die every year from air pollution, most of it from particulate matter from fossil fuels. Think of the number of people, think of what we've done to address the pandemic. Yet nobody talks about the air pollution. But anyway, I have a channel, paulbeckwith.net, and I've got over 1,500 videos, I think 1,500 by now on my YouTube channel. You can just Google Paul Beckwith YouTube, 15-minute videos. I just did a cross Canada tour where I dropped into different places. I went through one of the burned out forests in Red Lake, Ontario, Northern Ontario, and did videography as I was walking through the forest. I went to the site of the 1987 F4 tornado that devastated Edmonton, Alberta. I went by residential school sites. I did a lot of other stuff, but mostly it was environment and climate related, a bit of storm chasing and stuff. So, I encourage you to get as educated as you can about this. And we need to teach kids, young kids in the schools, that we need to do things totally differently because we're in a lot of trouble right now. So thank you.
Thank you very much, Paul. That was an eye-opening thing. I'm going to take there are questions in the pike. One is from Ted, and before that is from hang on.
John Meyer.
Bill, and from John Meyer. That's right. Quite a lot. So a short question from me, and then I'll turn it over to John Meyer. And then after that, Bill Pugsley. So you touched on it at the end. You used to call the kind of thing that one can do for the climate restoration. You're not talking about that so much anymore. I'm getting the feeling when I hear what you're saying. There's more desperation and less hope than there was even a few weeks ago.
Well, no, I mean, I don't, this stuff doesn't bother me in the least, by the way,
Ah,
right? Because if it did, I wouldn't be able to do like it did over many years, right? I've gone through all
yeah.
of these phases, and now it's just like, yeah, I mean, I do what I can to figure out what's going on and to educate as many people as I can and to try to propose different solutions and things. But nothing surprises me with the climate system. Like I think I've passed all, and a lot of it is
You've
there's a
gone through the
tremendous
stages of mourning.
yeah, there's stages of mourning, and now it's and there's stages of anger and all of this, but it's we have to try to salvage what we can out of the situation, but we also have to accept the reality of what's happening. And it looks like we haven't turned this ship around. The idea of people saying we have 5 years or 10 years to do X or Y, otherwise we're doomed or whatever. I mean, I never say that we're doomed. I don't think that, that doesn't apply to everybody, right? I mean, the idea of civilization collapsing is also another very silly one when you think about that, because it's not like all civilizations on the planet collapse simultaneously, right? They collapse in the weakest countries, the countries less prepared, the countries geographically situated to bear the brunt of climate impacts, and those things are already ongoing.
They're already happening.
They're already happening. They've been happening for a decade. We've put in more greenhouse gases in the atmosphere in the last 20 or 30 years than we put in prior human history before that. And the problem is that when the sinks of the earth are failing, like the ability of the plants to store carbon and the oceans to store carbon, then it really starts being taken out of human hands in terms of, we can cut our emissions all we want. We can cut our emissions down to zero, but if the earth isn't absorbing any carbon at all, then we're still on a wild ride to a much warmer, different world with no ice and snow in the Arctic and a complete rewiring of jet streams and ocean currents and all the rest of it. So, it's, there's a lot of different geopolitics that's going to happen. There's a lot of different unknowns, but, it's, you do what you can. I'm not responsible for causing that. I'm trying to prevent it. I mean, the reason why I want to educate people about all of this is just because, the reason used to be that to prevent it from happening, I guess. I figured if I talk, truthfully and candidly about all of the stuff I uncover about the climate system, and I get it out to as many people as possible, then maybe politicians will do things differently and people will do things differently and will prevent this from happening. Okay, that was my initial motivation for doing what I'm doing. And now now I realize that's not happening, right? It hasn't worked, right? So now my motivation is, well, this is what's happening. This is how our system is changing, and most of it is not for the good. But I don't expect anybody to do anything different to prevent this from continuing. So then I'm trying to project, where we're actually heading, what we're going to experience. Lots of people ask me, well, where should I live with climate change? Well, it's a lot easier to tell you where you shouldn't live, right? Like, you shouldn't live in the Gulf of Mexico, down next to the Gulf of Mexico. You shouldn't live along a river in Germany. You shouldn't. I mean, if you're in Florida, well, good luck. I mean, those sea level rise, the sea's covering your streets. In Miami on many sunny day flooding, right? And the sea dissolves limestone, and the buildings are sitting on limestone, and some of the limestone is turning into Swiss cheese, and we're getting condos collapsing. I mean, most people living in condos along the coast in Miami thought, well, I can put up with not being able to go outside a few days when the streets are flooding. But they don't like it so much to realize that the buildings, the high rises that they're in, are being undercut and tilting because of the sea level rising and causing building collapse. So that's a different ballgame, right? That's an eye opener for lots of people in Florida, for example.
Yeah, thank you. Well, yeah, I don't call that optimism. I agree with you on everything you said. John Meyer, you're up next.
Yeah, I don't know if we can stand to have our eyes any wider open, but we'll be peeling our eyelids off our foreheads. But that was great. Thanks. About 30 years ago, when I heard that Environment Canada had just gotten the Cray computer, as a layman activist, I tried to get them to do runs that would illustrate changing climate by calculating the extremes, where the extremes were going, how many extreme events there were. So my question is, now today, 30 years later, do we have a statistical, and Bill Pugsley says no, but do we have a statistical definition of extreme events, and do we count them? Do we know how many more extreme events are happening around the world annually?
Insurance companies like Munich Re, just go onto some of their websites and just have a look at some of their papers on climate change, and they keep track of global extreme events and then try to relate them, whether they're due to flooding or whether they're due to heat waves or whatever else. And they have to come up with some knowledge on that in order to keep their businesses going. So that's a good source. There's different, there's different ways to count it. For example, just a simple example for Ottawa. Okay, if you look at the number of, look at a given year and just count the number of times the temperature actually swings through zero. So, in the spring and fall, and even in the winter used to always stay below zero but there may have been a period of a week or two when it was fluctuating above zero, but it was generally cold. And now, if you just count the number of swings through zero, and divide it up into the different seasons, what you can see why the city some years has tremendous problem keeping ice off the sidewalks, for example. I remember a few years ago, it was almost impossible to walk in the glebe. City just kind of gave up. I think they ran out of money, and it was in March, and there was like glaciers on the roads with big ruts, and the sidewalks were impassable, and lots of people were just staying home and stuff, not going out. But so if you look at these, anytime there's a swing in temperature through zero, it wreaks havoc on infrastructure because, ice will melt, water fills up a pothole, then it freezes again, and then it expands. And if this is going on all the time, swinging back and forth, this is you could talk about weather whiplashing in many different scales, but that would be one example on a sort of local daily change scale. I mentioned a paper has just come out by Jennifer Francis and others. I think it's going through pre-review or something, but it's published online, and it's on weather whiplashing events. And, it's more larger scale things where, for example, in Antarctica right now, with the jet streams so distorted, there's some areas in Antarctica that are 40 or 50 below zero. And there's other regions very close to them that are above zero right now. Okay, they're like 10 degrees Celsius or something. And the difference is that, it's just where the jet stream is going. So when that jet stream moves, which it does, the phase of the wave moves, the peaks are over different areas of the ground, and the troughs are over different areas, and you get a huge swing in temperature. And that's in Antarctica, but nobody notices it that much except for people studying Antarctica. But just think of Ontario a few years ago. We had a record warm temperature in a March it was 20 degrees, 25 degrees some days in March, and people are walking around in t-shirts, and that persisted for a couple of weeks or 3 weeks. And then in early April, we had the wave moved, the jet stream wave moved, and we had very, very cold temperatures. So all of the buds and blooms that had started in the heat wave in March, they were all killed off. And I think we had $100 million loss in our apple crops, for example, in Ontario, just from that type of transition. So these weather whiplashing extremes, and they're most easy to see or to measure or know about in the hydrology regime. Like, as I mentioned, the Mississippi River, 3 years, going from flood record, drought record, flood record exceeding the previous flood record, right?
Okay.
And so we're just we can have we've all experienced extremely warm days, and then for 3 or 4 days it's extremely cold, and then it's extremely warm again, and that type of thing happening.
Yeah, okay, thanks.
Okay.
That's what I think we need.
So James
modification.
Hansen,
thanks.
James Hansen's done a lot of work on the statistics. So you can draw the normal curve of weather, with this is the mean temperature at the peak of the Gaussian distribution, and then the hot events, in the top few percent of the distribution, the very cold event. And what you can see is that the whole curve is shifting to warmer temperatures. So the average is going to warmer, the medians are going to warmer, and we're getting a lot more events falling under the curve at high temperatures, but we're still getting low temperatures. So the shape of the curve is also shifting. It's becoming more skewed. So James Hansen's done a lot of work over the years on that type of thing, and that's a good source for looking at the shifts, the variability and mean and other statistics of the weather.
Okay, thank you very much. Okay.
Paul, your questions are wonderful, but we're moving on. Art's got a question. I'm afraid I already know your answer. And Ted's got a question, and then I think it's Anitra.
Okay, Paul, thank you. I'm going to take it a little bit political. I know you've been involved in this for some time, and you've seen these COP conferences come and go, and I believe you have participated in at least one. Your comment that the next assessment report, at least the executive summary, is coming out on August the 9th, and I think that's very timely for COP26 coming up, and whether this will have any impact. Well, in fact, that's really my question. Do you see this conference of the parties in Glasgow this November? Do you see there's any greater probability of seeing global action? We've had nothing but commitments which everybody ignored up to time now. Are we going to see more of the same in your assessment?
I first attended the Lima COP in 2014. I got an email out of the blue from Stuart Scott, who has done a tremendous amount of work, and unfortunately he just passed away a couple of weeks ago. But I went to 2015 also and presented, that with the Paris COP, and I was in Madrid last year for that one, and I'm registered. I'm all set to go to Glasgow. It's in November this year, and I'll be doing. I usually do a lot of press conferences and presentations, etc., at these events, and I think people are starting to, you can only hit people so many times with a mallet before they eventually start to respond. And the climate extremes are hitting people around the world with mallets harder and harder, and more of them. I like a survey in Canada just showed that 49% of people, think we need to take strong climate action in Canada. And the reasoning is because they're experiencing themselves the smoke from wildfires. You know, it's affecting where they can go and what they can do. And, you know, if you have any medical conditions, asthma or whatever, you can be directly affected. So Europe, of course, is being completely devastated, a lot harder than other places. And it will continue to do that because unfortunately, you know, as the ocean currents are slowing down and bringing less heat over to Europe, meanwhile, the continent is heating by itself much more. And we're also getting occasional events where the ridges over the deserts of Sahara come up into Southern Europe, causing tremendous heat waves and problems. So Europe is being hit extremely hard. Britain just, you know, London had massive flooding the last few days, right? Massive rainfall over London. I mean, they're normally worried about the Thames River flooding, but this is, you know, a lot of London is on a floodplain, and, you know, the pictures of streets and cars, and, you know, the conference is in Glasgow. So, you know, I've stopped having a lot of hope that anything will be done. I was very hopeful after 2015, actually, you know, the Paris agreements and so on, but then we had Donald Trump coming in, right? And, you know, it's sort of like, you know, you can feel, you feel hopeful at some times, you feel less hopeful at other times. Eventually having your hopes dashed, you know, year in, year out on climate stuff. I mean, basically, the fossil fuel companies have won. You know, it's called state capture. They've captured the state. They're more powerful than the governments. And, you know, the lobbyists, you know, on governments, this is in Canada, the US government's completely precarious, you know, like they don't realize how close they are to losing democracy, many people there. So, you know, am I hopeful about a meeting of world leaders, which is COP26? We've had 25 without success of real change. The level of CO2 is still skyrocketing in the atmosphere. You know, we're getting more and more extremes. I don't see, you know, sure, I have hope. Like, hope is an important thing for humans to have, but you know, I can't say that I expect too much to happen.
Thank you.
I was afraid I knew that answer. Well, you kind of got political whiplash in a lot of places too. Some of them are south of our border. Not all of them. Anyway, it's Ted, and then it's Irene. And no, it's Ted first, then it's Irene, and it looks like Anitra has left.
Yeah, I'll be fast. Paul, I agree with you completely. You've answered most of my question already. Very fast question. How bad does it have to get their attention? And should we hold the next COP in Bangladesh if it's still there?
Yeah, I think having a COP in Bangladesh would be a great idea. You know, I think I think they'll reach a point where, like, what I'd like to see, I'd like to see governments say, you know, why do we have the military? Why does any country have a military? To protect the power, the people, you know, keep people safe within the country. That's what we're supposed to be doing, right? So now that the threat is this, you know, you can't fire a machine gun at a hurricane or drop a bomb on a flood. So the threats are different. The worst threats now are from abrupt climate change, right? So I'd therefore like to see that money. I'd like to see the military change its enemy for a few years to climate change. So imagine all those, you know, billions of dollars in the US military budget specifically, which just got an extra, they just voted, the Democrats just gave them an extra 30 billion or something to upgrade and their nuclear capabilities. You know, so the budget is what, 700 billion or something per year. And it's, you know, tens of thousands of scientists and engineers working in the different departments within the military. Let's see them work on addressing climate change for just a year to start off. let's say them say, okay, we've got enough guns, we can kill people efficiently enough around the planet. So how do we retool our society for renewables? What other energy sources can we use? What can we do in terms of removing CO2 from the atmosphere? Is it feasible to cool the planet, from the Arctic to preserve sea ice? Like what can we do to restore climate, right? Try to bring climate back to some semblance of stability before, the costs get too large. And eventually, yeah, cities are going to fall to a flood or whatever and just not be fixed.
Hey,
There won't be the money to fix them,
Thanks.
right?
As I remember it, Donald Trump wanted to drop a hydrogen bomb on a hurricane.
Yes, exactly.
Yeah,
Yeah.
I did.
Read it
Anyway,
apart.
yeah, that would have worked.
Mar-a-Lago makes a great target.
Yeah.
Of a hurricane too. Anyway, Irene, you're next. Are you there? Oh, well. Irene said Red Lake had a massive fire in 1980. People had to be moved out. And now 40 years on, the new growth is burning down.
Yeah, sorry, my mic was off. Yeah, so I had to go up there in 1980, and I pretty well had to wait until the threat was over. And then we drove up, and it was like being on the moon. So sad. Both sides of the road were black, desolate. And
Yeah.
what happens is a few years later, the trees really pop up because a lot of trees actually need a fire to be rejuvenated. So
Yeah.
they really pop up. But so many fires lately is a bit much, especially like
Yeah.
what's happening now in Northern Ontario and the West Coast.
Yes, my son went tree planting. He was between Red Lake and Iroquois Falls. He was up there for 2 months. So I took him there, and his friend's parents were supposed to pick him up, but they couldn't. So I went up the second time, and that's why I was up there. That's why I went on this cross Canada trip. The fact that I took an extra week and went as far as west as Banff is another story. But so I walked through those burnt out. They had another big fire just a year or 2 years ago, and the town was very, very close to being evacuated, but it wasn't. And I asked the local people where the fire had been, and it was just within 6 or 7 kilometers to the west of the town of Red Lake. So I drove along that road, and sure enough, you see, you go into this charred region where it's just burnt and blackened trees. And I think the fire was very fast moving because a lot of the pine trees, they were all completely blackened, but they were still standing, right? So it looked,
what happens, right?
Yeah, I walked through that region, and it was pretty eye-opening. But I could still smell, there was still a strong smell of smoke, but there were a lot of other fires in that region. And since I got back in the last week or so, they've had to evacuate over 3,000 people from some of those reserves up there because of the fires that are continuing right now.
Yeah.
See, the problem is we assume, okay, the forest burns down and then a forest will regrow. But if the climate has shifted, so there's less vegetation and it's a lot hotter, then the forest won't grow back. You'll get grass growing back instead. So a forested region will become a sort of like a savanna, maybe the odd tree, but mostly grasslands. And then if there's even less rainfall, it would become a grassland. So we can't assume when our boreal forests start burning down. I would say one of Canada's biggest threats moving forward with climate change is, we have forests everywhere in Canada, and imagine them being 10 or 100 times worse than what they are today. Will be smoked out and then they'll burn, but then eventually so many of them will have burned that the number of fires will be less because, an area that's burned isn't going to burn again, for many years. So.
And the other thing is the combination of fires and clear cutting for the timber industry.
Yeah,
Architects keep saying it's a renewable resource, and I really object to that expression
yeah,
because it's not a renewable resource when they're doing it much faster than you can renew.
that's right. They never
I-
mentioned the time lag. I mean, for a tree to capture a lot of carbon, it has to be somewhat mature, and also there has to be enough rainfall and, you know, conducive for the tree growth to absorb the carbon. If it's in a drought, it's not absorbing any carbon. It's not
New
growing at
Zealand,
all.
yeah, New Zealand is very proud of their tree harvesting.
Yeah.
I was going through there and I saw like a very high hill, and half of it was shaved and the other half was treed. And a resident, he was very proud. He says, "Oh, our trees grow twice as fast as in Canada." But the thing is, how many cycles can you sustain cutting down trees and leaching the nutrients out of the soil? You know, they don't think of that.
Yeah. Yes, that's, no, they don't. And, you know, if we're talking about a rainforest, like the Amazon rainforest, you know, the water is recycled so many times through the rainforest. If you cut it off at the beginning, you can affect the whole rainforest. And, you know, when they burn it off for their plantations or when they clear areas and so on, you know, with the climate having changed, those trees aren't going to grow back. It will, if they leave it be, it'll be more like a grassland than a rainforest.
In fact,
So
the Sahara
Uh,
Desert is a prime example because it used to be a lot smaller, but the tribes in the area pride themselves on their cattle, and also they use wood for burning. So basically the Sahara has expanded, and once it gets past a certain point, you just can't go back. So
Yeah,
we're going to be
certification.
yeah.
I'm going to have to move on. It's true, and I apologize. I skipped Bill Pugsley. Bill, do you have a question?
I think he's moved on.
Oh. Okay, I thought he actually had a comment that had been answered, but okay.
Yeah, Zach, Anitra left me a note. She had to go, but she wanted me to ask her question, which I think is the last one.
Go ahead.
Yeah, she was concerned about which areas would be most prone to famine because of major changes rapidly in climate. She and I are both involved with an initiative right now on food security through the Club of Rome. So answering that question could help us.
Yeah, I think that I still think that we're you know, in a great country to withstand you know, the ravages of most of abrupt climate change. I mean, that's been tempered a little bit by, you know, we have so many forests that can burn in Canada, right? I mean, how quickly, you know, if we continue to rise in temperature, and more of these things are burning, you know, how long will it take for, you know, the regime to change? Like, you know, are we going to be covered in smoke for decades and decades every summer? Right. So that's kind of tempering the thing that Canada is such a great country to be in for abrupt climate change. I thought we have lots of space and low population density, and we can always move further north. Now, the soils are, you know, regions of Northern Ontario, for example, are becoming much better potential for farming than they were just a few years ago. So, and there are some regions where there's still decent soil. It's not too far north. As you go further north, the soil is more acidic and it's much, it's not as developed, right? Because, you know, the glaciers scrape the surface, you know, and in the last ice age, and then it's taken time for soils to build up. And if there's not a lot of deciduous trees, then it takes an awful long time because you don't get the leaves falling each fall to start building up, decompose and build up the soils. So, you know, I think Canada is pretty good. You know, there was actually a study in the US of some of the best towns to live in with climate change. I think Duluth, Minnesota was was one of them. So being near the Great Lakes, you're going to have access to decent quantities of water, and so that's an area that was picked out in that study. You know, it's easier to say where you don't want to be, like I said.
So I did a similar modeling exercise decades ago, and pretty well identified the same sort of places: Northern Europe, the clay belt, the area north of Fort St. John, and so on. So if you were a risk management type now, the idea is move there for the next 50 years. Don't know if that works, does it?
Yeah, well, it's ongoing. You know, it's subject to change, right? The answer to that question, but I think you know, you know, also it depends a lot. You know, the forest, there's a lot we can do about the forest, right? We can clear away brush close to towns. You know, there are things we can do. We can build, we can stop, you know, we can, instead of just using asphalt roofs, it becomes a real problem. You know, we can just make sure we all go to metal roofs, that the metal roof industry takes over. You know, people in California are installing sprinkler systems over their houses, or maybe, you know, a solution is, you know, what about getting a massive, super thin fiberglass tarp, you know, and when the wildfires are coming to your region, you know, it's the embers that spread. The embers are picked up, and some of these fires are burning so hot that you get these firenadoes, even like a tornado within the firestorm, and you get pyrocumulus clouds creating their own weather system where you get a lot of lightning and stuff, but no rain, and that's setting fires, you know, tens of kilometers away from where the actual fire is, and the burning embers dropping on roofs and things. So, you know, if you had this fiberglass sheet that you just covered your house with every time, you know, one of these events was happening, so falling embers wouldn't set it on fire. You know, there's different things you could try, right? But also they evacuate places, right? So you have to say, well, no, I'm going to stay here with a hose on my roof or whatever, and then of course the water stops running and you're out of luck. So, you know, it's, yeah, you can try different ideas. Like there's not, I mean, we're not defenseless. We can try different things. At least it makes us feel good that we're trying something rather than just kind of like throwing up our hands.
Thank you.
I think Anitra was asking what regions of the earth, not just of Canada.
Yeah, so of the earth, well, I think New Zealand's pretty good, as long as the ozone layer holds up down there, right? Islands are pretty much they're more self-sufficient than you know, non-islands, right? You've got that island mentality sort of thing, but not Australia. Australia's, anywhere on Australia I'd stay away from, but New Zealand I think is good. I think, you know, Canada, I think Canada is good worldwide. I think we're going to have lots of, you know, we grow a lot of food and we'll continue to grow a lot of food. It might sort of migrate to higher latitudes. You know, maybe cities will start vertical farming and things like that very soon, because, you know, the temperatures that we're getting in overcrop growing regions is just too high. The crops, you know, go out to Saskatchewan and Alberta and, you know, the US, and crops are just withering in the field. You know, there's no harvest, too hot.
I don't
Okay,
have any more questions.
all right. So I'd just like to thank you, Paul, for this presentation. Would you be interested in coming back to us for a debriefing on COP26, say sometime prior to Christmas?
Yes, yes, I can do that. I'm, you know, the COP is very much up in the air. It's on right now, but if it's not, if they're not taking people, if things change, then there'll be a lot of things being done online for the COP. I'll be doing a lot of online presentations and so on. So it's going to happen in one form or the other. So yeah, I can come back and talk about my
Okay.
experiences there.
Okay, we'll start to look at a reasonable date and things offline. Of course, in thanking you for this presentation, I'd also like to remind all those who are not members of the Canadian Association for Club of Rome that they can join us just by going to our website at canadiancor.com, and the membership form is readily available there. Of course, we are a charity, which allows the dues which you pay as a tax receipt, and that takes a little bit of the bite off the $60 a year. Further, whether you are a member or not, if you're watching this on YouTube, then please do click on the red button, subscribe, and you will get early notification of all subsequent KCOR presentations. And with that, I would like to once again say, Paul, thank you very much for your participation today. And
Let me add my own personal thanks and a shout out again to paulbutler.net.
Beckwith.net.
okay.
Okay, thank you. Thanks to everybody listening in and watching the video.
Let me